So we got the answers up there for you. Which ones do we need to go through? First one. All right, so on that first one, you need to have the same base. You can't change the value of the base. You can rewrite it in a different form though. Okay, so some people have been we're trying to get this 3 to be a 9. You can't do that. It's a 3. But how can I write 1/3 with a base of 3? 3 to the negative 1. So I just change the format of the number. I don't change the actual value of the number. How could I write 9 as a base of 3? 3 squared. Good. Okay, so we just change what that number looks like. We don't change what it equals. Okay, and then when we have power to a power, we multiply, right? And since I have the same base of 3 now, what can I do with those two powers? Set them equal. So 2 times x minus 2 equal negative 1 times 3x minus 1. Is everybody okay with that? Okay, so then I've got 2x minus 4 equal to negative 3x plus 1. Add my 3x to both sides. So I have 5x minus 4 equals 1. Add my 4. 5x equals 5, so x is 1. Then when you plug it back in to do your check, make sure that when you put it in that power, you put parentheses around it unless you're going to do the mental math. On this one, personally, I would do mental math. I wouldn't take the time to type it into my calculator. But if you are typing it into your calculator, you got to have parentheses around that entire power. Otherwise, it won't take it to the entire power. Personally, I'd look at this and say this is 9 to the negative 1, or 1/9. This is 1/3 to the 3 minus 1 is second, which is 1/9. That's faster to me than typing in my calculator. But if that's not faster to you and you want to tell me whatever the decimal is for 1/9 on both sides, fine. If you type in your calculator, get decimal back, that's okay. This section, we typically round to the 3 decimal spots, so that's consistent all the way through this week. Friday included on the quiz, 3rd decimal space. So the 10,000, not 10,000, 1,000. Good? Do we need to go through B? Yeah? Okay. I have logs on both sides. So in order to be able to say this thing equals this thing, I have to have only one log on both sides. So what do I have to do on the right-hand side to make that to 1? So we condense, which is multiplication. So the plus means to multiply. So log base 7 of 8x. So then now what can be equal to each other? 4 equals 8x. So x is 1/2. When you check that, remember we talked about yesterday, you always go back into the original, because if you screwed up when you condensed and say you decided that that was a division problem instead of a multiplication problem, if you plug it back into your already condensed form, your answer will be correct. Probably, unless you did something screwy when you were solving. But if you plug it back into the original, you'll find out your answer is not correct, and then you'll go back and look for your mistake. So always go back to the original. How do I type that into my calculator? Change base. Log 4. Really? Divided by log 7. Okay, so you have to do the change base multiple times throughout that phrase, because it's got log 8 divided by log 7, log 1/2 divided by log 7. Again, if you plug it back into what you already condensed, and you condensed wrong, you will not catch your mistake. This is the original, right here. You plug this in and you type it in. If you do this as log base 7 of 8 times 1/2 or 4, you've condensed it. What if you decided that this was a division problem? You would still think it was a division problem here, and you come up with your answer working, but when it really doesn't in the original. Okay, so you don't want to condense because you don't want to do the same error twice. You want to find your error. Okay? All right, what about the inverses? 10 to the x minus 2 equals y is part A, and B is 3 to the x minus 7 equals y. So am I thinking yes on both? All right. First thing you got to check when you're trying to do an inverse is, have I switched my x and y yet? No, so I'm going to switch my x and my y. X equals log of y plus 2. It is a base of 10. Perfect, because 10 is, when there's nothing there, it's a 10. Is my log base whatever of something by itself? Yes, because when it's in parentheses, that's one thing, right? So whatever's right after the log is attached to the word log. So it's by itself, so I change it to exponential. So what's the base? We just said it. To what power? X, good, equals y plus 2. And then we got to subtract 2. Now when you subtract that 2, can you subtract it from the exponent, or are you subtracting it from that whole side? Whole side, perfect. So we got 10 to the x minus 2. All right, do we need to go through the second one? Yes? Okay, switch your x and your y. Is log base whatever of something by itself? No. I need this by itself. Random smartboard issues. Okay, how do I get that by itself? Good. So I got x minus 7 equals log base 3 of y. Now is my log by itself? Yes. What do I change it to? Exponential. What's the base? What's the power? What does it equal? Okay? Anything I didn't cover? Okay? Okay, because then what we do today is take the solving methods we did Friday and yesterday, and we apply it to the word problem stuff we were doing at the beginning of the chapter when we did compound interest and compounding continuously. So remember our formulas. A equals P times 1 plus R over N to the NT. N is when we had a number of times compounded. A year. And when we had PE to the RT, that was compounding continuously. So when it said we're compounded this many times, we use the first one. Continuously, we use the second one. So you're depositing $700 in an account that pays 2.75% annual interest. How long does it take the balance to reach $1,000 when the interest is compounded quarterly? So which formula am I going to use? The first one, because it is in a year, but both of them are in a year. It's not continuous. It says compounded quarterly. Now, one of the issues people were having when we did this last time is they see the word annual by interest, and they get confused on what their end value has to be. All interest, when you're talking banks usually, is said as annual interest. This is the amount of interest we will give you for the year. Okay? It's a rate that they're going to calculate it at for that year. The compounding is how many times they actually run your money through this formula. That's our 4, or our n. Okay, so when it will say annual interest, that does not mean you're going to use a 1. It's how many times you compound it a year. That's your n. Okay, so we know n is 4. What else do we know? 700 is p. What else? A is 1,000. Good. Because we want to reach 1,000. And then, but we're instead of 2.75, you're going to put in. Okay, so what are we looking for? Time. Perfect. How long does it take? That's my t. Okay, so in our formula, we know the A. We said it was 1,000. Equals P, 700. 1 plus R is 0.0275. You told me N was 4 because it's quarterly. To the power of NT, or 4T. Now herein lies the issue. Our exponent is in our our variable is in our exponent, which is why we're doing it now. How do we deal with it when the variable's in the exponent? Why are we dividing by 700? You're absolutely correct. Good. We need this thing alone. I'm going to just put a little dot up here, thing to the power. You got to get the thing to the power by itself. Okay, this is what we did on Friday. There was only one number to a power. Whatever this is inside the parentheses to the power, that has it's not powers on both sides like we did yesterday. So we're back to Friday's method. Get the thing by itself, so we divide by 700. Now, 1,000 over 700 does not give a nice decimal, correct? When it doesn't give a nice decimal, to save you from rounding errors just getting worse and worse and worse throughout the problem, leave it as a fraction. If you can reduce it, reduce, which you can here, because 1,000 and 700 are both divisible by 100. We know that this is 10/7. But if it's not a nice decimal, leave it as the fraction so that you're not rounding now and then rounding again at the end. It's all going to end up being typed into your calculator anyways. Same thing with what's in the parentheses. If it's not a nice decimal that ends fairly soon, so you're not typing 6 million digits back in, leave it as what's there, and then you're going to type the whole thing in your calculator anyways, so it's just a matter of when you type it. So let's type it at the end so we don't round and then round and then round. Okay? I'm to something to a power equaling a number. What did we do on Friday to solve that? We could get the same base. Are either of these nice numbers to try and find the same base of? No. Okay, so we can't do that method. Go back further. Go back to Friday. 10/6, the first day. When you have an exponential problem that you want to solve. You could change it to logarithms, or you can take the log of both sides. You got to pick. Which one do you want to do? Okay, log base what? I'm sorry, which one did you say? Okay, change it to a log then. Nope. What's our base? What's the base up here? What's being taken to the power? So that's the same as the base of your log. Of what? 10/7 equals 4t. Okay, so that's going back to your base power equals. Same thing we just did when we did here, where we went 10 to the x equals y plus 2. We went to 10 to the x. So where do we get that from? 10 is my base. X is my power, goes on the other side of the equals. Whatever was next to it is your y plus 2. Okay, so we need to be able to solve for t. So We are going to have to do change of base on the top, and then in the end, you're going to end up dividing by. So again, I'm a fan of just typing everything in at once rather than rounding multiple times. You have to do the change of base up on the top. You're right. So we're going to do log of 10/7 divided by log of 1 plus 0.0275 divided by 4. You're going to take that answer, you're going to divide it by 4. No, you don't have to write out that step. I'm just showing you what you would type into your calculator. Absolutely. And time for interest problems is always measured in years. 13.015. Did you put parentheses in just like I put parentheses in? There's an issue. You good now? Okay. Last step is to check. Did we get an exact answer there? So when we check, when we plug that in, are we going to get back exactly 1,000? No. Okay, so you're going to type that in. Make sure you put parentheses around your power. The 4 times the 13.015 needs to be in parentheses. And you're not going to get back exactly 1,000 because you rounded to get 13.015. But you should come out close. How close are we? You're not typing something right. Okay, so is it becoming apparent why I say you got to have parentheses in certain places? Without the parentheses, your answers are coming out wrong. Use your parentheses. Your calculator does order of operations. If you only have a number after the caret key, it's going to take it to that power and then multiply that answer by whatever the next thing is. If you don't put the parentheses there, it'll take this 1 plus 0.0275 divided by 4 to the 4th power, get that, multiply that answer by 13.05, and then multiply, well, and multiply by 700 at the same time. Okay, so order of operations gets followed by your calculator. You have to tell it when you want to bypass that. That's why we put parentheses there. Okay? All right. You've deposited $500 in an account that pays 6.75% interest compounded continuously. How long will it take for your money to double? Which formula? Yes, we use the other formula. We're continuous now. A equals P times E to the RT. Okay? Do we know what A is? Why? Good. We want our money to double. We're starting with 500, so A is? Okay, what else do we know? What else do we know? P is 500. What else do we know? Good. What are we looking for? T. So we've got 1,000 equals 500. E, because you don't plug anything for E. E is a number. R is 0.0675 to the T. Okay, what do we need to do? We are going to have to do the ln, but before we can do the ln, what do we have to get by itself? Absolutely, this has got to be a loan. Yup. So we get 2. Now, you already told me that we're doing the ln because we got to undo an E. ln stands for log base E. So we're doing the same process we just did on the last one, except instead of writing log base E, we're writing ln. ln of what? 2. Good. Equals? Absolutely. The power, 0.0675 T. How do I get T by itself? So we definitely like E's better for this type of process because there's less typing involved. Because it's easier to do ln of 2 in your calculator. Make sure, though, that you finish that parenthesis after the ln. And our label is years. Years. Always years. Am I going to get exactly 1,000 with this one? Do I need parentheses? Yes. So make sure you get those parentheses around your power. He's doing his check first, Sam. I'll answer it. That's what I'm here for. Yes. Correct. So close enough. You rounded to get your answer. You're going to be slightly off on your monetary value. Good? Okay. The next one is a review, well, not really a review. It's like the one we just did. And the 3 on the back are all review. So I'm going to have you work on your own now while I can come around and help. The answers are right here. And then we'll go through what you have questions on. I'm doing more helping individually, so does everybody have these answers written down? And so that I can help people individually with them. I'm also passing out the worksheet, which is your homework. And the book page tomorrow is your review, so I'm handing that out as well. Make sure you bring your book with you to class tomorrow so that you have it to do the review. That is wonderful that you bring your book to class every day. You are a prepared student. You guys are going to have issues. Okay, did everybody get one? Okay, so your assignment then is the worksheet 7-6, but then you need your book tomorrow for the review. You do get a day to work on the review tomorrow.